everyone. Okay, so in this video, we are looking at the rate of change and what does it mean? So what is rate of change? Well, that is the study of calculus. Calculus is the study of rate of change. How are things changing in relation to other things? So that is what we've been studying with calculus, but now it's kind of time to apply it to real world things. So we need to make sure, so a rate of change is a measure of how one variable changes with respect to another variable. A derivative is often described as a rate of change. So if we have a positive rate of change, it is increasing. We say something's increasing. If it has a negative rate of change, we say something is decreasing. So how do we say these? So dy dx, we say the rate of change of y with respect to x. dv dt, the rate of change of volume with respect to time. dA dr, the rate of change of area with respect to the radius. So it's important to be able to interpret the meaning of the derivative of functions and modeling real world scenarios. So let's have a look here. The average weight in kilograms of an ash tree is given by this function, where h is the height of the tree. But I already am thinking, okay, well, if the tree is getting taller, it's probably going to weigh more. So I'm thinking it's going to have a positive rate of change. So find WH and what does it mean? So the first derivative of WH, and what does it mean? So my first derivative is 4h plus 3. And describe what it means. It just means the rate of change of the weight of the tree with respect to its height. And we see here, it's a linear term. That means going up. The rate of change is going up. So when the height is increasing, the weight is increasing. So evaluate the derivative of our height for the height of 5 meters. So sub in my rate of change for 3. That is equal to 23 kilograms per meter, right? So at that point, the tree is gaining 23 kilos, right, for every meter it grows. What are the units of measurement? Well, the units of measurement, like I said, are kilograms per meter. So how much weight I'm going up per meter of height. Will this be positive or negative? Like I said, it's a line. It's positive. It's going to be positive because if the tree is getting bigger, that means it's obviously going to weigh more. The tree doesn't get taller and then suddenly start to lose weight. That makes no sense. Let's look at some exam questions. This is from 2024. Fia put money in a savings account and leaves it there for a number of years. The following expression FT is the amount of money in the account in euro after T years. So use differentiation, find the rate at which the amount of money in the account is increasing after 3.5 years. Give your answer correct to the nearest euro. So we need to find f of t. Well, this is an exponential, so I just multiply by the derivative of the power here, and the derivative of that power is 0.04. So 0.04 multiplied by 5,000 and e power 0.04t. That will be equal to 200e to 0.04t, and we're evaluating that at t is equal to 3.5. So sub that in, 200 times e to the power of 0.04 times 3.5. That will give me roughly 230 euro per year. So the rate at which my money is increasing 230 euro per year at that particular moment. All right, let's have a look at another one here. 2021. Water is flowing into and being removed from a tank. The volume of the tank is measured on a daily basis, starting at day 0. The volume of a tank in liters in the tank can be modeled with this formula. So the volume of the tank can be modeled with this formula, where T is time in days. So find the value of t when the tank empties. So when the tank empties, the volume is going to be equal to 0. So let's solve for 0. So I have here, I'm just going to change all the signs here. So 3t squared minus 41t minus 60 equals 0. And I'm going to have here 3t was 0 minus 15 plus 4. So I get t is equal to minus 4 over 3, and t is equal to 15 days. Now we have to look here while I'm dealing with days, and can I have minus 1 1/3 day? No. So we do not count that answer. So my answer is actually 15 days. So the water's being flowing out of the tank, and then takes 15 days for it to be empty. How fun. Right. Next one. Find the rate at which the volume of the tank is changing when t is equal to 5. So find the rate at which the volume of the water is changing. So I'm looking for dv dt. That is equal to 41 minus 6t. Evaluating that at t is equal to 5. 41 minus 6 times 5 is equal to 11. So the rate there is 11. Find the value of t. Find the value t for when, So find the value t when the volume of the tank is at its maximum. So if it's at its maximum, the first derivative equals 0. So 41 minus 6t is equal to 0. Then that's going to be equal to 6t is equal to 41. T is equal to 41 over 6 days. Find the maximum volume of the tank. Well, I know what happens when t is equal to 41 over 6. So sub it in. V 41 over 6. So wherever I have t, I'm putting in 41 over 6. And I get here to roughly 200 liters. That's the maximum volume of water in the tank, correcting this liter, right? So 200 liters. Right, let's look at another one here now. This is 2019. The weekly revenue produced by a company manufacturing air conditioning units is seasonal. So it's seasonal. So that's why they're modeling it with a trig function, because it oscillates every year. So we're selling more peak time like summer, then winter, no one wants one. Back to summer again, no one wants one. Back to summer, no one wants one. Back to summer, etc., etc., etc. So can be modeled with this function. Find the approximate revenue produced 20 weeks at the beginning of July. Give your answer correct to the nearest 0. So just so t is equal to 20. That's just 22,500 cosine pi over 26 times 20 plus 37,500, which will be roughly equal to 20,659 euro. Find two values of time t within the first 52 weeks where the revenue is approximately 26,250. So I have to let now my function equal 26,250. So this is actually a trig equation. So 22,500 cosine pi over 26t plus 37,500 is equal to 26,250. So 22,500 cosine pi over 26t plus that plus is equal to 26,250 minus 37,500 minus 11,250. Divide both sides by 22,500. You get here cosine pi over 26t is equal to minus a half. Now I set up my trig equation here. So it's negative. So sex and the city. So it's negative. So that means it's in quadrant 2 and quadrant 3. That's my reference angle. We're doing a radian, so pi minus my reference angle, pi plus my reference angle, and 2 pi minus my reference angle. So my reference angle will be pi over 26 cosine inverse a half. Cosine inverse of a half is equal to 60. But I want it in radians, so right. So my reference angle is going to be equal to 1/3 pi. So my first angle is going to be 180. So pi minus 1/3 pi, which is 2/3 pi. And my second angle is going to be pi plus 1/3 pi, which would be 4/3 pi. Now, I just let pi over 26t equal 2/3 pi. So I can divide across by pi. I have here t is equal to 2/3 times 26. Which is equal to t is equal to 17.33 days. And then pi over 26t is equal to 4/3 pi. Divide across by pi, boom, boom. I'm going to have here t is equal to 4/3 times 26. T is going to be equal to 34.67 days. Perfect, right? So, find the derivative of this function. Okay, so, well, this will go to 0. So, my first derivative is equal to, so 22,500. The cosine goes to minus sine. So I'll put the minus in front. Sine pi over 26t. Make sure to multiply then by the derivative of the angle, which is pi over 26. So my answer here is 22500 divided by 26. This will just be equal to minus 11,250 pi sine pi over 26t all over 13. And that's it. Use calculus to show the revenue is increasing 30 weeks after the beginning of July. So T's number of weeks from the beginning of July. So we want to show this increases. So I say days in these parts. I mean weeks. You know what I mean. Weeks. Anyway, you know what I mean. I meant weeks there. Right. We want to show it's increasing. Is it increasing, is it? Increasing. So if my derivative is greater than 0, therefore it's increasing. So it's minus 11250 sine pi over 26 times 30 all over 11. Put that in my calculator. Minus 11250 sine pi over 26 times 30 over 11. That is equal to 475.29, which is greater than 0, therefore increasing. Finally, find the minimum value for the time t within the first 52 weeks when the revenue is at a minimum. So I see the word minimum, so first derivative equals 0. So dr dt is equal to 0. So I have minus 11250 sine pi over 26t all over 11 is equal to 0. Multiply across by 11, divide by minus 11 to 50. I get sine pi over 26t is equal to 0. So drawing out a little sketch here, right? If sine is 0, that means it's in the first quadrant. And it's in the second quadrant. Right? Because if its sine is 0, that means it's on the little axes here. So, find my reference angle. My reference angle is going to be just 0 degrees. And then here, pi minus my reference angle, there'll be my second angle is equal to pi minus my reference angle, which is equal to pi. So therefore, I have my two equations here. Pi over 26t is equal to 0. Therefore, t will equal 0. And pi over 26t is equal to pi. 1 over 26t is equal to 1. Therefore, t is equal to 26. So it will be at a minimum 26 weeks away. Right. And that is rate of change. So we're going to look at one more application of rate of change in the next video. We're going to be looking at displacement, speed, and acceleration. I hope this video will help you guys. I'll catch you guys later. Bye.